Hello, physics students. I am Mr. Williams, and today we're going to talk about the layers of the Earth and how we can infer that the layers of the Earth are there by using what we know about earthquakes. Okay, earthquakes, they give two types of waves out. We have our primary waves, remember that fast push and pull wave, and we have secondary waves, the slower moving side to side shearing waves. Okay, and if you remember, the P waves, they can go through a solid, liquid, or gas, but the S waves cannot go through a liquid or gas. So when you use that information, you can determine that if S waves do not go through, if we don't detect S waves on the other side of the Earth, then there is a liquid there that does not allow those waves to go through. And so that's how we can infer that there is um, liquid within the earth, right? And we'll talk about it more. And so another thing that I'm just going to touch on, I'm not going to quiz on this, there's something called the transition zone. And the transition zone is a newly discovered layer of the earth. It is said to exist between the upper and lower mantle, and it's theorized to be this mineral water. Okay, water has the ability to become chemically bonded to rocks, sometimes called hydrates. But this type of water is even more unique than that, and I believe it's called water 4. And it is theorized to be just like this water within these minerals. And so often we just refer to the mantle as the mantle, but you can break the mantle down into different regions as you do that. But something to think about, some new stuff that's been out for about 15 years. Pretty interesting thing. Please ignore my, you have 60 seconds to write this. I timed these slides in the classroom, but we don't have to worry about that now. So there are many discontinuities or discontinuities, whichever way you want to say it, that exists. So anytime there's this abrupt density change between the Earth's layers, okay, that's a discontinuity. Okay, and the Mohorovic discontinuity is a just a particular boundary that marks an abrupt density change between Earth's layers. Okay, now we have this thing called a shadow zone. This is a dead zone between 105 and 140 degrees from the earthquake's epicenter, where nothing is recorded on a seismogram. Okay, don't get too hung up on the 105 and 140 degrees. Basically, S waves, for example, S waves will not travel through liquids. And so when you have S waves not traveling through liquids, if there's an earthquake on one side of the earth, you're not able to sense the vibration on the other side. When we say sense the vibration, we're talking about seismographs and instruments that scientists put in the earth to measure these um, earthquake waves that go through the earth. If there's a earthquake in China, you don't feel it on the other side of the world, for example. But you would be able to record it with instruments that you had put into the dirt. And so there is this shadow zone where you would expect to see S waves and it's not there. And we're theorizing that it's not there because there's a liquid underneath the earth. This is not the transition zone I'm talking about. We're believing that this is the liquid core that blocks these. Okay, the asthenosphere is a weaker semi-solid plastic-like layer beneath the Earth's crust. And they call that the lithosphere, on which the tectonic plates move around. Right? Sometimes they call it the lithospheric plates. Don't get too hung up on this terminology, but I just want to introduce to you that there are parts of the crust, right? In fact, it's very putty, like the deepest hole ever dug. Drilled a hole, and they were trying to go all the way through the crust, and then eventually they said it was just like trying to drill through putty. It was like no longer drillable. It was just mixing around. Pretty interesting stuff. Maybe you should Google or YouTube the deepest hole ever drilled. So in general, we already talked about this. Um, the discontinuity is just a boundary that marks an abrupt density change between Earth's layers. Okay, and that transition zone that I'm introducing you, that's just a layer of the Earth that separates the upper mantle from the lower mantle that contains mineral water crystals. Wish we had time to go in through this because it is a really good example of how you can take evidence to draw conclusions on, right? Like, how do we know this? What evidence do they use? But unfortunately, we don't have time to do that. So what's inside the Earth? Okay, seismologists, they study earthquakes, and the waves created from the earthquakes are used to measure the different densities of the Earth. Essential, especially for your quiz, to know that we are able to study the layers of the Earth because of earthquake waves. Okay, so we have these primary waves, P waves, and S waves, the secondary waves. They're created from earthquakes and they travel through the Earth, and they are measured on the opposite side of the Earth. And since S waves cannot travel through liquids, the different densities of the Earth's interior are able to be inferred. Oh, S waves aren't coming out on the other side, so we believe that there's liquid inside the Earth. Simple, right? Is the Earth just one big solid rock? Well, no. All right. If Earth were one solid rock of uniform composition, the earthquake waves would travel a predictable path to the opposite side of the Earth. Okay. Observations, however, they show that waves travel at different speeds throughout the Earth. The waves change speed as they travel through different densities from different materials, right? When you have that, you have a change in speed through each discontinuity, right? The abrupt layer change due to different densities. When they change speeds, they change directions. Earthquake waves bend as they encounter a drastic change in density, just like I said, and each density change is known as that discontinuity from our vocabulary. Now, one of the famous ones is called the Mohorovic discontinuity. It's what separates the crust from the mantle. That'd be that first major change. And new research suggests that water being present at the Moho rocks, the different composition of the rock could show as a discontinuity density change. Okay, and some new information. Now, these are some animated GIFs that kind of show the different shadow zones. So the one on the left is the P waves. Remember, P waves are faster. P waves are able to go through solids, liquids, and gases. So let's look at the one on the left, okay? So we have an earthquake, and as the earthquake emanates its waves, it goes through the different layers. And as it changes a layer, it changes the direction that it goes, right? We'd expect it to emanate out in a perfect circle or sphere, but we see that there are areas where it doesn't go. And so even for P waves, because it the way it changes direction, there are areas where in P waves we expect to see them and they're not just because of refraction. They change direction as they go through a different density. Now on the right side, we're looking at S waves. On S waves, there's a much larger shadow zone. The shadow zone is just like this area where we expect to see S waves if the Earth was solid, but we don't see them there. So we have this large shadow zone, okay? And that large shadow zone is blocked, we believe, by the liquid outer core, okay? So there's a visual aid of it. And so here is a little textual version of this, okay? So on the top of that picture, you see those are the S wave shadow zones because S waves are blocked by the liquid core. And on the bottom, there are the P wave shadow zone. We have like two of those zones, right? Because the waves are changing direction. So when we observe the waves coming from the epicenter, the P waves and S waves are traveling through the Earth at a 105-degree arc. in all directions. So they travel in that 105-degree arc. Up here, they have them as 103. And between 105 and 140, from the epicenter, no waves are transmitted through the other side. And for the most part, that's because there's no P waves. From 140 to 180, that's where we only see the P waves. So at the top, from 103, there's this big blank spot all the way down here, very blank. We see no waves. And that bottom bullet is saying we don't see any waves here. We don't see any waves here. But in the middle, we do see the P waves, because P waves are the only things going through. Since we know P waves can travel through liquid, right? We know that the waves are able to travel through. And so we believe there is a liquid core that the P waves travel through. They do change direction through refraction, but we don't see any S waves. So we think there's a liquid core that is blocking the S waves. And that's the idea of how we know the Earth has layers. And this is a little bit what I explained. The S waves do not appear on the seismographs from 105 degrees. And it's believed that there's a layer of Earth absorbing them, right? A liquid layer. The outer core is the liquid. Remember, S waves only travel through solids. Because earthquakes happen all around the Earth, we're able to map out the center of the Earth from many different perspectives. Okay, and we're actually able to find even just hot spots around the Earth, like maybe there's more magma underneath the Earth in one side than the other, and that's something that's been coming out recently as the last year. And again, the fact that P waves pass through the center of the Earth but are refracted along the way, it is inferred that the inner core is a solid and denser than the outer core. Okay, so we know that the inner core is solid and the outer core is liquid. Awesome. And so, what is the composition of these layers? Earth's internal layers become denser with depth. The crust and upper mantle form the lithosphere. They're made of rocky material like silicates. Right? Silicates are like silicon and oxygen uh, containing minerals. And of course, we have you know, the calcium and other metals that we know of. This thenosphere is a weaker plastic-like layer beneath the lithosphere. Remember when I said as we start drilling really deep into the crust, it just turned to putty? Yeah, it's that plastic-like layer. And so that when you go below that layer, you have the mantle, and it's under a lot of pressure. It's extreme pressure. So much pressure, rock is able to be melted, um, and it's a very thick, viscous material. It's believed to be the similar composition, the silicates of the crust, but because it's under so much pressure and so much friction, it's able to get real hot and melt. Okay. And this is just, it's something we got the crust up here, we got the mantle, we have the outer core of the liquid core, and then we have the inner core, that solid core. So Earth's internal layers become denser with depth. It makes sense, right? More pressure, and so there's going to be more material in a smaller space. And the crust and upper mantle form the lithosphere, which we said that, and are made of rocky materials. I think I just said this. Oops. Yeah, I did say this. Did I go the wrong way? My bad. The core is believed to be made of metallic materials such as iron and nickel, and that is what is believed to give us our part of our magnetic field, convection, and uh, is said to give us that dynamo magnetic field as well. But metals are dense, and it's believed that they settle to the core over time. Right, the solids would settle, and the heavier, more denser things are, the more they would go towards the center of Earth's gravity. All right, guys, that is how we know the Earth has layers. All right, things you need to know for this quiz. Okay, um, you need to know how those shadow zones are formed. All right, don't get hung up on the degrees. What you need to know is you need to know that the P waves show up on the other side of the Earth, but the S waves don't. Okay, the S waves are blocked by the liquid core. That's something you need to know. Um, know what the layers of the Earth are, and just understand that it is these earthquake waves that tell us what these layers of the Earth are. Okay, you need to know that the inner core is hard, and it's believed to be made of iron and nickel and maybe cobalt. Um, you need to know that the outer core is liquid. You need to know that the mantle is above the liquid core, and then there is a crust. Okay, so guys, that is all we're going to cover in terms of the layers of the Earth. Have a nice day. Bye.